Friends, today we are going to discuss a very important parameter or particularly happen in centrifugal compressor that is called surging and Stonewall point. So if you see the picture here, this is a compressor, this is a receiver, this is a receiver from atmosphere. Uh, Atmospheric air is taken and compress it and then it is giving to the receiver. So these are the different when the compressor now when the before compressor starting the receiver and the compressor having the atmospheric pressure. When you start the compressor, compressed air will go to the receiver and as it is a compressible fluid, so initially there will not be any pressure rise, only there will not be any resistance to flow also and only pressure drop will take place in the line and pressure is going to build up. Flow will be maximum and pressure is going to reach very slowly. So initially the flow will be maximum, that is the point number one, and then as it is a compressible fluid, it will take some time to build the pressure, and when the pressure will build up, right pressure will build up, then we will get the point 2. This is more or less the straight line. From here to here, from point 1 to point 2, the flow is not stable. This point is called the Stonewall point. Stonewall point. From here, you can see for very little flow difference, the pressure will go on dropping. Very little flow difference, the pressure is go on dropping. So this one is called the Stonewall point. And if you keep the compression running, then gradually the flow will reduce because the pressure inside the receiver will build up. So this will create resistance. Flow coming inside the receiver will reduce and pressure will increase and we will reach to the point 3. This one is called the rated point. This one is called the rated point. And if you keep the compressor running, then again pressure will build up, but flow inside the receiver is filled up. So going flow, volumetric flow going inside the receiver will come down and pressure will increase. But pressure will increase, and beyond this one is called the you could call surging point, and beyond this point the compressor cannot rise the flow, and because no flow will go to the receiver, unable to flow any giving any flow into the receiver, and pressure will like this to the maximum. If you keep the compressor running, then what happen, due to some reverse flow from the receiver, the flow will go to the compressor and compressor pressure will come down, and then again compressor will start acting and give some flow to the receiver again. So this thing will go on happening periodically over a cycle. So this cycle is then called the surging. This cycle is called the surging. Flow will come receiver side to compressor again, compressor side to receiver. So this receiver, so this is go on happening frequently with a cycle, and this one is called the surging. You see, these are the different RPM performance curve. If you see the highest, the 100% rated RPM, 100% RPM, then from here it is called the Stonewall point. From here, flow will be maximum, pressure will be the minimum. Pressure difference means P2 by PS, suction pressure by discharge pressure, minimum. Then gradually the pressure will increasing, flow will decrease because system will pressurized, flow inside system will go on reducing, and then when it will reach to up to this point, then compressor cannot develop further pressure, and the reversible failure will take place from receiver to system to the compressor, and then pressure will slightly come down. Then again compressor will start discharging, and it will reach here discharging, and this cycle will go on happening periodically. So minimum flow, this is the minimum flow point and highest head point. This is the minimum flow point and highest because the highest pressure point, head point. The velocity become too slow for compressor to perform stably because as the pressure increasing, so flow going inside the receiver or system will be reducing, so velocity will be reduced, and compressor to perform stably. Then too slow for compressor to perform stably, go on fluctuating. Flow reversal can happen from here. Flow reversal will happen from system to the compressor. If surging continue, it can cause severe damage to the compressor. Hence, surge control device are installed. That's why surge control device are installed. We cannot keep the compressor running with the surge condition, because sometimes flow will take place, sometimes reversal flow will take place, so the cycle will go on. So it is not allowed because it will damage the compressor permanently. Surging can cause a damage to the thrust bearing also, because flow is take place reversible side. So thrust bearing due to rotor shifting from active side to non-active side. That's why the thrust bearing and thrust bearing, thrust collar, etc. May get damaged. This is called surge cycle, and the surge cycle is go on happening 0.3 second to 3 second such intervals, such interval. And so what is the Stonewall point? It is the maximum stable flow. This is the maximum stable flow point, and minimum head. This is the minimum head. These are the minimum. This is the minimum head 100 RPM. This is the minimum head at 90% RPM. This is the minimum head at 80% RPM. This is the minimum head at 70% RPM. Operating beyond this Stonewall point is unpredictable. If you slightly increase the space volume, the flow will fall. Flow will fall. So for this point also, it is unstable. Stonewall point is also unstable. Surging point is also more unstable. So we have to avoid this 2 point, and you have to keep the point shifting so that it can be operated in the running point, that is here, and that is 10% beyond the such capacity, beyond the surge point. Anti-surge control device detect when the when the proper gas compressor stage is approaching to surge, and take action to move the operating point away from the surge line. This is the surge line. So when this will come to up to this point, this anti-surge controller will take action and will increase the flow so that it cannot reach to the up to the surge point. This is achieved by opening the control valve in a recycle line, in the recycle line, discharge line to the suction. It will go to the discharge to the suction, so the flow will increase, and it will anti-surge valve will take action. We can say the anti-surge valve will take action, flow will increase, so it will go away from the surge point. This increases the suction gas flow and moving the operating point away from the surge line. To be safer side, the surge control line is 3 to 10% of the right side of the surge line and parallel to it. 100%, and that is 90%, 80%, 70%, 10% from the 10% from the surge line. 10% from the surge line, where anti-surge valve will take action. So I think the Stonewall point and surge point is very clear. Stonewall point is the maximum stable compressor flow point. Consequently, the minimum head point under compressor operation. Flow increases. If flow increases beyond this Stonewall are minimum at the best, minimum at best. The operation beyond the Stonewall point is unpredictable, because the head will fall down, because vertical slope of the curve in this area. Manufacturer will usually stop their curve before they reach this vertical section. Yeah, so they will not allow the compressor to run beyond this point, beyond the Stonewall point. And surge point is the minimum stable flow point, minimum stable flow and maximum height, consequently the highest height point, and the pressure in the receiver continue to increase. When the pressure in the receiver continue to increase, the volume flow rate into the receiver become less and less, and therefore velocity of gas going through the compressor and into the piping continue to decrease. Means this when the you see the when this is a receiver, when the flow is going to, when it is full, the flow going to the receiver through the piping is reducing, is reducing, is reducing, is reducing, unstable, is reducing. When the velocity become too slow, the compressor can no longer perform stably. Since the compressor pumping action is unstable, a flow reversal can take place. Unstable, it cannot go further discharge, so reversal flow can take place. And with flow reversal, the volume in the receiver decreases because reverse flow has taken place. So volume in the receiver will decreases, and so does the pressure also. When volume decreases, pressure also volume decreases, so pressure also decreases. Pressure also decreases. Pressure, so does the pressure, and compressor then again provide the positive flow. Then when the volume decreases from the receiver and the pressure decreases, then again compressor will start discharging. In severe cases, surge become cause the destruction. That means it is a back to forth flow motion called surging. Back to forth flow. When sometimes flow reversible, sometimes forward. So this back and forth flow take place. This one is called the surging. This can severely damage the damage and destruction. A good rule of thumb is telling that 110% flow through the compressor reaches 110% of the surge flow capacity. 110% capacity. The good thumb rule is to start the recycle process when the flow through the compressor reaches 110% of the surge flow capacity. The This approach essentially yield 10% safer factor to allow for machining tolerance and instrument valve to lag time. This is 10% margin we have taken. This 10% margin, this 10% we have taken because the valve need to take some time, some time to operate. So before that, it should not reach to here. So that 10% time, 10% before that 10% volume and pressure, it will open the anti-surge valve. It will open the anti-surge valve. Surge take place at low flow and highest pressure condition. Stonewall take place at high flow and low pressure condition. If you see, the surge flow will take place low flow, diesel flow is less, and high pressure condition, and Stonewall high flow, low pressure condition, low pressure condition, low pressure condition. Level condition. To avoid surging flow to the compressor to avoid surging flow to the compressor to be increased, because from there increased anti-surge valve is provided at the compressor discharge line. This is when flow reduces, anti-surge valve open and flow through the compressor increases, which means loss of energy. And similarly, if the vent valve provided as a discharge line, we have to open it and increase the flow, which means loss of energy as well as loss of material. Hence, it is advisable to run the compressor away from the surge line 110% of the surge flow capacity. 110% of the surge flow capacity. So, if your surge flow capacity 110% of the surge flow, if 100 flow is this, then 110% of the capacity with the surge flow will operate. If surge flow will control anti-surge valve will do, it will recycle the discharge to the suction, so the flow through the compressor will increase. That means the energy will increase. Anti-surge valve open means energy will increase. Or there may be a vent valve. If you open it, then also energy will increase, as well as the flow through the compressor increase. The energy is increased, as well as you are losing some material also. You see, this is the compressor. from compressor, this is the upstream side. We are taking the PT, PT means pressure transmitter, the temperature transmitter, flow transmitter, and discharge side we are taking the temperature transmitter, pressure transmitter, giving it to the signal to the anti-surge control valve. Anti-surge control valve study where the position of the compressor running, and accordingly it will give signal to the anti-surge valve, and then anti-surge valve, and anti-surge valve will open, and after that cooler discharge, after this cooler, if you don't open this after this cooler, the temperature will be the suction temperature, so it will go through the suction again. But it must, but the anti-surge valve should be provided at the discharge line and after the cooler, no, before the cooler. If you take before the cooler, hot air will go. So hot air, hot process fluid will go. So it should be after the cooler, after the cooler. Now compressor mapping, this is one is called the compressor mapping. If you see the vertical line, this is PD discharge minus P1 divided by P1. This is the head, this is the head, and this is the volumetric flow. This one is the surge line, the red one is the surge line, blue one is the anti-surge point, operating point, anti-surge control point. If it is reached this point, it will start opening the valve. Opening the anti-surge valve means there is energy loss, but you can shape your compressor. But this much margin is required because to operate the anti-surge valve, operate any valve, it will take some time. Though we are making anti-surge valve to open quickly, but still it will require some time. By this time I have to give, that's why 10% margin we have taken. You see, this is the again the pictorial value. This is the flow transmitter, then pressure transmitter, then temperature transmitter, and discharge side, the pressure transmitter, temperature transmitter. All this signal will go to the anti-surge controller, and anti-surge controller will give signal to the anti-surge valve. And from the after the coolant, the anti-surge valve coolant, from the discharge line, some flow will take place to the suction to the compressor again, to this turbine. This is the compressor again, so that the flow will be away from the surge line, away from the surge line. And there is a difference which is between the general control valve and the anti-surge valve. The main difference is that the surge control valve has a certain required to be opened as fast as possible to avoid surging. That's why though we have been keeping a 10% margin, but normal control valve will take some time. Anti-surge valve will open quickly, but still it requires some time. That's why 10% margin has been taken. But this is not like a general control valve. The difference between the general control valve and anti-surge valve is that anti-surge valve will open as fast as it can. You see, this is the anti-surge position. This is the anti-surge operating procedure. We are giving it here. We'll explain in the next slide, the bigger one. The next slide, how this is operating. You see, this is the valve, anti-surge valve. This one is the anti-surge valve, and this is the actuator, pneumatic actuator. The actuator which will open this valve open and close conditions. This is the position I2P positioner. This I2P positioner. This is the instrumentation air through regulator, and this is the receiver. In case of any emergency, if you fail to get the instrumentation air, then through this receiver air will go to the the actuator, and these are the booster. You see that this one is also one more booster which is mounted at the bottom, through the three-way valve, and this is another booster which is position and gives pneumatic air to the top of the actuator with the three-way pilot valve. This is the solenoid valve. This is also a two-way vent valve. This is the position. This is the IP positioner. This is 13 is your it's called the transducer. It will give the signal where is the position, where your valve position, and it will give signal to the controller. This one is the controller, and this is the limit switch that will, if you come beyond this, the valve will close. If you go open it beyond this, automatically this is a limit switch. Yeah, you will come to know whether valve is open and closed condition. Now no, when you are taking the anti-surge in line, anti-surge valve in line, this through this controller, the solenoid will remain open condition. Solenoid will remain energized condition. Energized condition. Then signal will go to this three-way valve, three-way valve, and this three-way valve. Signal will go to this three-way valve, and from the I2P positioner, I2P positioner, you see the transducer, it will give signal to this controller, and from controller also signal will come to the I2P positioner. I2P positioner will decide which through actuator, through the pneumatic valve, which side this will go to the bottom of the actuator. One will go through this booster to the top of the actuator. In case any emergency, what will happen? Here it will happen. This valve will de-energized, and when this valve will de-energize, this air will block here. Downstream will go to drain, and similarly this two-way valve also open, and the top side of the actuator will open, and bottom side will the actuator will through this the volumetric volumetric booster pressure, air will come at the bottom side of the actuator, and it's open the valve quickly. It's open the valve quickly. If any signal is failed at that pneumatic air is not coming, then that's why the receiver has been kept nearby. From here also the signal, the pneumatic air will go to this booster, and this will help for quick opening and quick closing the valve. This is the another drawing of the anti-surge valve. This is the positioner. You see, this is the positioner. From this compressed air will come, and the signal will come from the controller, and accordingly the signal instrumentation will go to the top of the piston and the bottom of the piston, and valve position will be checked by this feedback lever. When this valve will open, means this side pressure will increase, valve will go on increasing, valve will go on increasing, this air is going to decrease, and this position with this feedback system, this will keep the pilot piston again in the center position, so that this will arrest, this movement will be arrest the position where it is required, and accordingly the flow will take place through this. So why inlet temperature, pressure and flow and outlet temperature and pressure are measured to control the surge control of compressor? Compressor. Why? Why we are taking three, that is the parameter, the pressure, temperature and flow at suction, and discharge temperature and pressure are discharged for control the anti-surge valve. Now in compressor, anti-surge control system measuring the inlet temperature, inlet pressure and flow, and outlet temperature and pressure is essential, because surge is fundamentally related to flow versus pressure rise under given gas condition. Let's condition. Then if you see what is surge, now this is the surge occur when the compressor cannot sustain the forward flow. It cannot discharge forward flow. So flow reversal will take place, cause vibration, damage and instability. And the surge limit depends on the actual gas condition. So surge limit depends on the actual gas condition, not just the raw flow. Because why? This measurement as required the inlet pressure and inlet temperature. This is defined as control the density of the compressor suction. The pressure increase, density will increase. If pressure decrease, density will decrease. If temperature increase, density will decrease. Pressure reduce, density will increase. So this will control the flow. The flow meters usually measure the volumetric flow, but surge depend on mass flow, not the volumetric mass flow. And mass is depend on the pressure and temperature and pressure. So if temperature increase, density decrease. Actual mass flow decrease. That means mass level, we have to close the surge valve. And when pressure in decrease, density decrease, and same effect. Density decrease, then same effect. Pressure decrease means same effect. Temperature increase means again density decrease. I have to close the valve. Pressure decrease, density also decrease, same effect. So pressure and temperature used to measure the flow into corrected mass flow required. Then flow measurement. This is the most critical parameter. Such happen at low flow. We have known the control constantly check how close is the current flow to the surge flow limits. Surge flow limit but raw flow alone is not enough, but it must be corrected with pressure and temperature. I have shown you pressure and effect of pressure and temperature on the density of the molecules and the mass flow and the mass flow. So outlet pressure is what will happen. Now this will indicate the load on the compressor, higher discharge pressure and higher compression ratio. When the discharge pressure is high, so P2 by P1 is also high. So surge line shifted depending on the pressure ratio, because we have shown you the pressure ratio surge line curve. If you show the surge line curve, this is depends on the pressure ratio. You see the pressure ratio D2 minus D1 by P1 pressure ratio. Pressure ratio depends on the pressure ratio. Surge line is depend on the right hand side, left hand side vertical line depend on the pressure ratio. Depend on the pressure ratio. So pressure ratio. Pressure ratio, that is P2 by P1. So P2 help determine where you are on the compressor map. P2 and flow both will decide where you are at present now. Varying the compression process is healthy. Estimate the polytropic and isentropic performance. Then it is also indirectly confirm gas condition changes. If the gas condition changes. Now you have get the corrected flow as per the pressure and temperature, and corrected pressure also, discharge pressure P2 by P1 also, and you can come to know the where is your position, your compressor is running, whether it is anti-surge control valve does not use raw value, they not use the corrected value, and the valve will operate only on the corrected value, corrected flow, pressure ratio. So anti-surge valve will not depend on the raw value material. It depends on the corrected flow, that is corrected by temperature and pressure ratio also. These define your position relative to the surge curve, where you are at present. When what the controller actually does, using all parameter, it calculates corrected flow, because corrected flow depends on Q1, P1 and T1, and pressure ratio P2 by P1. That's why the suction pressure, temperature and flow and discharge temperature, pressure and temperature are important to see the corrected flow and pressure ratio. Compares the operating point with the surge line, you will get the corrected point, compare it with the surge line, and then open and close the anti-surge valve. This is the anti-surge valve opener to safeguard your compressor. So why all parameter together? Now parameter why needed? Why parameter why needed? Now inlet pressure density correction. Inlet pressure is required for density correction. Inlet temperature is required for density correction. Flow detect low flow conditions. Flow meter will take whether where is the flow. Outlet pressure define the compression ratio. Outlet temperature performs and safety validation, temperature validation, and then think like this. Surge depends on how much gas or mass is flowing and how hard is the compressor is working. Pressure rise, flow as well as the pressure rise, and then inlet condition define how much flow, how much gas, or outlet condition define how hard is your working, P2 by P1, or how much flow. Left hand side will give on how much flow, right hand side pressure and temperature give on how hard your compressor is running, and final decision. All these measures are required because such function is of corrected mass flow and pressure ratio, not that raw flow. Raw flow, it does not depend on raw flow, it depends on the corrected flow, and without correcting of our temperature and pressure, the anti-surge system would give wrong decision and potentially lead to the false trip of the compressor. That's why corrected flow and corrected pressure ratio is important. That's why suction temperature, suction pressure, suction flow, discharge pressure, discharge temperature is to be measured and corrected it. So I think I have cleared your knowledge about surging. This is only happen in compressor, compressible fluid and Stonewall point. Stonewall point is the high discharge volume, low pressure. Surging point is your low volume, high discharge pressure. Both are are not stable condition of running. So if you go the highest Stonewall running beyond Stonewall point, your flow, your pressure will come down. It's unpredictable. Similarly, surgeon is very dangerous because if you reach to the surging point, then reversible flow take place. Compressor will move to and fro. It will damage your thrust collar, thrust bearing, internals of the compressor, and it go on happening periodically. So you need to open anti-surge valve so that your flow through the compressor will increase and you are away from the surge point. And normally surge point we are keeping 10% of the surge flow because to open the valve it takes some time. Anti-surge valve are not like the simple control valve. It is it required to open and close very quickly to keep the compressor running in safe condition. That's why the boosters, since both actuator upwards and downwards were provided, so that upward will going to drain, downward below the actuator it will go pressurize, so immediately valve will open. Similarly, valve will close when the discharge, when the upward is pressurized, and upward of the control of the diaphragm will pressurize, and downstream is going to drain, it will close immediately. Surge anti-surge is energy consumed, so you have to try to avoid the anti-surge valve open condition. So you have to close it, or if you using vent also, then not only the energy, you are losing some materials also. So choosing how to run your compressor efficiently depends on the anti-surge valve operation. Thank you very much. If you have any doubt, you can talk to me and mail me.